I teach a class available to all students, not just mechanical engineering, but well, everybody from MIT. I've had students even from architecture. So the purpose of the class is for students who want to use machine learning in their everyday professional life, but they don't want necessarily to become computer scientists, right? So we give them a lot of the fundamentals of machine learning, rigorously the mathematics and the mathematical foundations, as I would say. But we also try to link with engineering applications that go beyond the traditional machine vision and computer science. So as it happened, when the pandemic struck in March 2020, I was teaching that class, and the class also has projects. The students need to carry out a project as part of the requirements. And as you can imagine, many of the students chose to study epidemiology using machine learning. And one of them actually became really super dedicated to the topic. And we ended up co-authoring a paper with his advisor and with a student. His name is Raj Dandekar. And not only that, but it ended up becoming the main topic of his PhD thesis. I stayed involved as a member of his doctoral committee. Of course, by now he has gone way beyond what we did in that paper. And I was very proud of that. It's one of the cases where I think it shows the true MIT spirit, because there was a real problem facing everybody. And you have a bunch of students who are very smart, but they're kind of beginners, right, in this area. They were taking this class because they wanted to learn from scratch. And yet, when the problem struck and they sensed that they can contribute, they really sped up really fast. And they ended up doing, peer review quality work, which is amazing, right? And I was really proud. And I'm very proud because this is not the first time that this class has produced publications. It has happened also in the past, maybe not under circumstances that are as dramatic as this one, but certainly the class has produced publications. It was great, it shows that the gap really between teaching and research is not really all that great. If you structure the teaching experience right, and if you give the students the right incentive and the real guidance, then actually they can cross over the boundary. Maybe not very easily, but they can certainly cross over the boundary, and that's spectacular when it happens. The MIT is ideal for this, and I think most of it is tradition. MIT sort of perhaps since its foundation, has been very appreciative of these kinds of interactions, especially bringing fundamental research to practice. My favorite example is Professor Norbert Wiener, who was a professor at MIT, of course, in the 1930s. And you can see a lot of his pictures when you walk around the hallways down on the first floor. And he was one of the best mathematical minds ever, like a real mathematician. At the same time, he influenced a lot of applications, a lot of the algorithms that were developed later during World War II, especially for radar, and he also coined the term cybernetics, by the way, and a lot of other things that were actually shockingly applied for a mathematician, right? And yet he was not afraid to do it. And I don't think anybody minded at MIT. In fact, quite the opposite. They were, delighted that Wiener did all of this, and we still celebrate him today. So to me, he's one of the icons, and of course many others. Professor Millie Dresselhaus, Professor House, all of them have passed away, but I did have the privilege to know them when I was a young professor here. And they were similarly minded, brilliant scientific minds who had no fear about going into applications as well and working with industry. And I think it is great for us who are younger, and even younger, our students, to aspire to continue this tradition. This is really what MIT is about.